algorithm. So the examples for algorithmic design techniques are brute force, divide and conquer, dynamic programming, or the algorithmic design technique. So the first technique is called as brute force. Under brute force, we discussed selection sort, bubble sort, string matching, right? The fourth subtopic is closest pair and convex hull problem. Okay. So under brute force, we discussed selection sort, bubble sort, and string matching, right? The next topic is closest pair and convex hull problems. Okay. So this closest pair problem is nothing but used to find two closest points, which is used to find two closest. So the closest pair contains set of points. Closest pair contains set of points. Among these points, we can find two closest points. Okay. Next, the formula to calculate two closest points, Euclidean distance formula. D is distance, D within bracket, Pi, any 2 points, Pi, comma, Pj, right? In the square bracket, xi minus xj the whole square plus yi minus yj the whole square. This Euclidean distance formula is used to find the two closest points, right? This is used to find the two closest points. This is the pseudocode of closest pair. Algorithm. Name of the algorithm is brute force closest pair. Insect brute force closest pair within bracket points, set of points. Okay. Among points, we can two close pair. Okay, two closest points. Input is list of points. Input is list of points. Okay. N represents number of points. N represents number of points. So the n value should be greater than or equivalent to 2, right? N should be greater than or equivalent to 2. Okay. The 2 points are x1 and y1. X and y are the 2 points. Now, output will be the distance between the two closest pair of points. Distance between the closest pair of points. Okay. Next, D. D is nothing but distance. The initial value of distance is infinity. Initial value is infinity, right? Now, for I loop is from 1 to n minus 1. N represents number of points. N represents number of points. J equivalent to I plus n, right? So the formula to calculate the distance between D equivalent to minimum of D comma square root of xi minus xj the whole square plus yi minus yj the whole square, right? So instead of square root symbol, we used sqrt function. Okay. Instead of in this previous formula, instead of square root symbol, we used sqrt function. SQRT is square root, right? SQRT square root. Okay. Finally, we'll return the distance between 2 points. Okay, pa? This is the pseudocode of brute force closest pair. So no need of write the iterations, right? No need for any iterations. Just write what do you mean by closest pair, write the formula, write the pseudocode, and then we are going to discuss about the time analysis. Okay. Now, how many summations we need to write here? How many summations we need to write? 2, right? Because we have 2 for loops in the pseudocode. So we need to write 2 summations. What will be the output? What will be the time analysis? If we have 2 for loop, 2 summations, what will be the time analysis?
N square, ma'am.
N square, good, N square. Okay, if we have only one for loop, then we need to write one summation. Our answer will be N. Okay, here we have two summations, N square. Okay, this is the pseudocode of brute force closest pair, right? Next is time analysis. In the time analysis, this is the time analysis. C of n is equivalent to summation. Now tell me the two summations. What is the first summation?
I is equals to 1 to n minus 1.
Yes. Next summation is
J is equals to I plus 1 to j is equal to n.
yes, I plus 1 to n, right? 2 represents 2 points x and y. Clear, everyone? Now, let me open share the screen, whiteboard. Okay. Is it visible?
No, ma'am.
Oh, okay. Now is it visible?
Yes,
Is it
ma'am.
visible?
Yes, ma'am.
Oh, yeah. Now I'm going to write the time analysis of close. Tell me, Pa, what happens?
Whiteboard has not visible, ma'am.
Okay. What about others?
It is visible, ma'am.
மேம் எனக்கும் தெரியல மேம் விசிபிளா இல்ல
Okay.
மேம்
Not
ஒரு
visible.
வாட்டி பேக் கொடுத்துட்டு கிளாஸ்க்குள்ள வாங்க, இன் பண்ணுங்க. கிளாஸ் ஓகே, ஒரு வாட்டி லீவ் ஆயிட்டு ஜாயின் ஆகு.
ஓகே மேம்
யா. Thursday வந்து நமக்கு டெஸ்ட் இருக்குப்பா, நம்மளோட டிஏ எக்ஸாம் இருக்கு, இன்டர்னல். ஃபர்ஸ்ட் யூனிட் கம்ப்ளீட்டா, அப்புறமா இதுல வந்துட்டு ஸ்ட்ரிங் மேட்சிங் வரைக்கும். ஓகே, 1.5 யூனிட்ஸ். கிளியரா
Okay, ma'am.
ஸ்டூடெண்ட்ஸ்? ஓகே. Screen is visible, pa?
எஸ் மேம் இப்போ தெரியுது மேம்
Yes, ma'am.
Okay, fine. Yes. Zoom in, zoom out பண்ணிக்கோங்க, தெரியல அப்படின்னா. Okay, so now the first summation is I equivalent to 1 to n minus 1 summation j equivalent to I plus 1 to n. 2 represents 2 points x and y. Now apply seventh formula to seventh formula. Now write the first summation as it is 1 to n minus 1. The second summation is upper limit minus lower limit, upper limit minus lower limit plus 1. Okay. Now cancel this minus 1 plus 1 equal summation I equivalent to 1 to n minus 1 n minus I. Okay. Now, is it clear? Up to this clear?
Ma'am, what happened to the 2, ma'am?
Which one? Yeah, that
2.
we need to, yeah, that we need to write. That we have to write. Upper limit minus lower limit. Write this 2 before summation, okay? Let me write. Listen, before this summation, 2 summation I equivalent to 1 to n minus 1. So n minus I plus 1 plus 1. Next. Now 2 summation I equivalent to 1 to n minus 1 I minus 1 plus 1. Okay. Now cancel this minus 1 plus 1. Now 2 summation I equivalent to 1 to n minus 1 n minus I, right? Next we are going to break down this n minus I into 2 summations. Now 2. Okay, one more thing. Now apply formula number 2. Okay, apply formula number 2. Let me write the formula number 2 over here. Now note down the formula number 2. I'm going to write the formula number 2. Formula number 2 was summation I equivalent to 1 to n I equal 1 plus 2 plus up to n equal up to n equal to n into n plus 1 by 2. Okay, pa, n into n plus 1 by 2. Now, what is our upper limit in the summation? Upper
N
limit in
minus
the
1.
n minus 1, right? Upper limit is n minus 1. Now, I equivalent to 1 to n minus 1, right? So now, here in this I, right? In this I, we have to submit I equivalent to 1 to n minus 1, right? Here we need to substitute I equivalent to 1 to n minus 1. Now how to do the substitution? Instead of the summation, that 2, right? It is already on the sum within bracket n minus 1, right? N minus I. So instead of I, substitute I equivalent to 1 to n minus 1. Clear, Appa? Is it clear? Is it clear?
Yes, ma'am.
Okay. So it depends upon the formula. The first n minus I is 1 plus n minus 2 plus n minus 1 plus n minus 2 plus etc. The last term is n minus 1 upper limit. N minus 1. The 1 is the lower limit. 1, 2, 3 up to n minus 1. Okay. Now
Ma'am, once again you tell, ma'am, confusing. What we should substitute for I, ma'am?
for I, we have to substitute I equivalent to 1 to n minus 1. Okay. Clear? See the formula. Okay. Let me try to write in the PPT. Not
மேம் இல்லனா அந்த சமேஷன்ல இருந்து அத செப்பரேட் பண்ண முடியுமா மேம் n-ஐயும் i-யும்
இது சொல்ற
ஃபர்ஸ்ட் வந்து 2 into I is equal to 1 to n minus 1 n minus 2 into summation I is equals to 1 to n minus 1 I.
அப்படி வந்து நம்ம சப்ஸ்டியூட் பண்ண முடியாது. அதுக்கு செகண்ட் ஃபார்முலா பார்த்தோன்னா this is the second formula. ஸ்க்ரீன்ல தெரியுதா? ஃபார்முலா நம்பர் 2. ஓகே.
எஸ் மேம்.
ஸோ இதுல ஐக்கு என்ன சப்ஸ்டியூட் பண்ணியிருக்கோம்? ஐ ஈக்குவலன் டு அதான் இதுதான் சப்ஸ்டியூட் பண்ணியிருக்கோம். இதுதான் ஃபார்முலா நம்பர் 2. ஸோ இன் தி ஃபார்முலா ஐ ஈக்குவல் திஸ் இன்ஸ்டெட் ஆஃப் திஸ் ஐ என்ன சப்ஸ்டியூட் பண்ணியிருக்காங்க? ஐக்கு பதிலா 1 plus 2 plus etc. n. Okay, that's all. Right? I equivalent to 1 to n. So 1 plus 2 plus upper limit is n, which is equivalent to n into n plus 1 by 2. Right? So instead of this I, what we are going to substitute? What we are going to substitute instead of this I, n minus 1 to n minus 1.
Okay, ma'am. Now I understood, ma'am.
Wait, otherwise I'll write. Okay, understood?
Yes, ma'am.
Yeah. Okay. Now, 2 within bracket n minus 1, n minus 2 plus the last term is n minus upper limit is n minus 1. Okay, which is equivalent to 2 n minus 1 plus n minus 2 plus cancel n and n. That is n minus n plus 1. Cancel this n minus n. Now the remaining term is 2 n minus 1 plus n minus 2 etc. plus n. Now, which is equivalent to depends upon the formula. What is the formula? Which is equal to n into n plus 1 divided by 2. Okay, this is the formula. The second formula equal to 2 n into n minus 1 plus 1. Now this minus 1 plus 1. Remaining term is 2 within bracket n minus 1 into n divided by 2. Okay. Finally, we'll get cancel this 2 and 2. Final answer is n minus 1 into n. Okay. Which is equivalent to n square minus n, which is belongs to n square. Highest order of n is n square. Okay. I'll explain it again. Next is okay. So now first summation is summation I equivalent to 1 to n minus 1. Summation j equivalent to I plus 1 to 2. Okay. Now apply. So the middle இருக்கிற steps தான் நான் explain பண்ணேன். Right? Apply the seventh formula to the second summation. Seventh formula is minus lower limit plus 1. Now Now the upper limit is, I am solving the second summation, right? Apply formula number 7. Formula number 7 is upper limit minus lower limit plus 1. Upper limit minus lower limit plus 1 equal n. Students, ஒரே நிமிஷம். Hello? Hello? சார் சொல்லுங்க சார். ஆமா ஆமா, ஆக்சிஸ் பேங்க்ல பண்ணியிருந்தேன் சார். Lajua. Okay, next is upper limit is n minus lower limit I plus 1 plus 1, right? Now n minus I minus plus 1. Okay, now cancel this minus plus 1. Clear pa? Cancel this minus 1 plus 1. Cancel this minus 1 plus 1. Cancel பண்ணிட்டோம். Now remaining n minus I. Now write 2. We are going to write, okay, now 2 summation now summation upper limit is the first summation n minus 1 and the lower limit is I equal to 1, right? Here we have n minus 1. N minus, okay, n minus now Okay, now we are going to apply the formula number 2, right? Formula number 2. Now formula number 2 was, see, this is the formula number, summation I equivalent to 1 to okay, this is formula number 2. Right, this is formula number 2. Now we are going to write the summation based on this formula. Now, this is the formula. Equivalent to, again insert summation summation. Okay, no need to write the summation. Equivalent to 2 within bracket. So in the formula, we have I equivalent to 1 to n. Okay. In the summation, we have I equivalent to 1 to n minus 1, right? So instead of I, substitute n minus 1. Clear, everyone? N minus 1. Next, plus, next substitute n minus 2. Plus, next, what is the next substitution? Wait a minute, we'll download the attendance. What is the next summation? Next is
n plus
yeah,
n minus n plus 1, no, ma'am.
yes. Next line. Now, n minus within bracket
n minus 1.
n minus 1. Good. N minus 1. Okay. Next. 2 within bracket n minus 1 plus n minus 1, n minus 2 plus, now we have n minus n plus 1. Okay. Now cancel this minus n plus n, right? Cancel minus n plus n. Remaining term is 2 within bracket. Cancel this n minus. Okay, remaining term is n minus 1 plus n minus 2 up to 1, right? Now, so look at the formula. This whole term is equivalent to n into n plus 1 by 2, right? So now we can write 2 within bracket 2 into now here the upper limit is n minus 1. In the formula, upper limit is n. So we wrote n into n plus 1 by 2 in the formula. In our summation, upper limit is n minus 1, right? So we have to write n minus 1 into n minus 1 plus 1 divided by 2. Okay, pa? Now cancel this minus 1 plus 1. Remaining term is 2 into n minus 1 into n divided by 2. Okay. Finally, cancel the and 2. Cancel 2 and 2. Remaining, we have n minus 1 into n, right? Which is n square minus n. Okay. N square minus, which is equivalent to n square. That's all. Any doubts here? Any doubts in the derivation? So in the derivation, நம்ம detailed இப்படி எழுதியிருக்கோம். Okay. Any doubts here? This is called as what? Closest pair. Okay. Any doubts, pa?
No, ma'am.
Okay. This is called as closest pair. Okay. Next, convex hull problem. Right. Next is convex hull. Next topic is convex hull. Next is convex hull. This is called as convex hull problem. Before going into the topic, we discussed about convex set. Okay, so convex set is a set of points. Convex set is a set of finite or infinite points, right? Set of finite or infinite points. So the first shades are called as convex sets. Okay, the first sets shades are called as convex sets. The next shades are not a convex set. Okay, the first four are the convex sets. The next are the sets that are not convex. Sets that are not convex. Okay, now, so the example for convex sets are right line, triangle, rectangle, polygon, circle. Okay, so the set, the convex sets are right line, triangle, rectangle, convex, polygon are called as convex sets. Okay, so now this representation is called as rubber band interpretation of the convex cell. So the outline, the border is this outline points are called as endpoints or extreme points, right? This border points are called as extreme points or end points, right? Now here the endpoints are P3, P1, P3, P7, P6, P5. Okay, the endpoints are otherwise called as extreme points. Endpoints are otherwise called as extreme points. Okay, now this P1, P3, P7, P6, P5 are called as extreme points. Okay, finally, you just complete this topic with the time. No need of write any analysis pseudocode for a convex hull convex set. This convex hull problem is nothing but it's a small theory topic. You just write what is convex set. Draw three diagram for convex set. Draw 3-4 diagram for not convex set. Next, draw the rubber band representation of the endpoints, extreme points. Next, write this. So here, it's a convex cell. Set, this capital S is nothing but set. Okay, the set contains number of points. So the point should be greater than n is nothing but set of points. N should be greater than or equivalent to 2, right? So this outline, this border points are called as end, end points or extreme points. Okay, the extreme points are P1, P3, P7, P6, P5. Okay, finally write the time efficiency of this algorithm is இது வரைக்கும் எழுதிட்டா போதும். Time efficiency of this algorithm is big of n cube. Okay, no need to write any algorithm or pseudocode, right? No need to write any algorithm or pseudocode. Convexel. Next, the next topic is exhaustive search. Okay, next topic is exhaustive search. This exhaustive search is nothing but exhaustive search is used to find all the possibilities. Okay, exhaustive search is used to examine or find all the possibilities, right? So among these possibilities, we have find the optimal solution. Okay, among these possibilities, we have find the solution may the optimal solution may be minimum or maximum, right? So what do you mean by exhaustive search? Exhaustive search is the search is used to find or examine all the possibilities, right? Which is used or examining all the possibilities. Among these possibilities, we can find the optimal solution, right? So the optimal solution may be minimum value or maximum value. The optimal solution may be minimum value or maximum value. Okay. So under this exhaustive search, we are going to find we are going to discuss three problems such as traveling salesman problem, knapsack problem. The third one is assignment problem, right? We are going to discuss the three problems such as traveling salesman problem, knapsack problem, and assignment problem. Okay. So what do you mean by exhaustive search? Which is used to examine or find all the possibilities. Among these possibilities, we can find the optimal solution. The optimal solution may be minimum value or maximum value. Okay. This optimal solution may be minimum value or maximum value. So the three problems can be solved by exhaustive search or traveling salesman problem, knapsack problem, and okay. So first problem is called as traveling salesman problem. First is called as traveling salesman problem. This traveling salesman problem is used to find the traveling salesman problem is used to find the shortest distance or shortest path. Okay, which is used to find the shortest distance or shortest path. Okay, now consider n cities. Consider this graph. So here n cities are called as number of cities. Okay, so this traveling salesman has to visit all the cities exactly once. Traveling salesman has to visit all the cities exactly once. Here we have four cities A, B, C, and D. Okay, four cities A, B, C, and D. This traveling salesman problem working based on Hamiltonian circuit. Hamiltonian circuit. The definition of Hamiltonian circuit is starts and ends at the same vertex and visit all the vertices exactly once. Okay, start and ends at the same vertex and visit all the vertices exactly once. This is the definition of Hamiltonian circuit. So the traveling salesman or salesperson problem is based on Hamiltonian circuit. Okay, now consider the salesman is traveling from city A. Okay, city A. Or consider the pizza delivery man is traveling from Coimbatore to Pundamalli, right? The shop is in Coimbatore, so he starts from Coimbatore, city name A, right? Again, he needs to visit all the cities B, D, and C. Finally, he needs to reach the same city A. Okay. Finally, he needs to reach the same city A. Clear? So Hamiltonian circuit is nothing but starts and ends at the same. For example, the person starts at A, again he needs to end at A, right? In between, he visits all the city exactly once. Okay, all the city exactly once. This is called as what? Hamiltonian circuit. This is called as Hamiltonian circuit. Clear? So this traveling salesman problem is Used to find shortest path or distance. Used to find shortest path or distance. Okay. Which contains n cities. The traveling salesman has to visit all the cities exactly once. This traveling salesman problem using Hamiltonian circuit, right? Hamiltonian circuit is nothing but starts and ends at the same vertex and visit all the cities exactly once. Okay, the cities are called as vertices, right? Vertex is called a city. Vertex is called a city. We have four vertices in this graph: A, B, C, and D. The four vertices are A, B, C, and D. Okay. Now we are going to find the distance, right? So initially, the person starts at A. Starts at A. From A, what is the next path? Now I'll tell you. I'll explain you the first path. From A. A is the source. From he visits. Okay. Again B. He visits D. From D, he visits C. Again from C, he back to the source A. Clear? Now, C, we visited that particular salesman visited all the four cities A, B, D, C, finally reached the same vertex A, same city A. Now the distance from A to B. Okay, what is the distance between A and B? What is the distance between A and B?
2, ma'am.
Edge value. Edge value is the distance, right? Edge value is the distance. That is 2 plus B2D,
3,
B2D 3 plus D2C 1.
1,
Yeah, plus C2A
5,
5, right? What is the total distance? 8,
11.
10, 11. Okay. See, next. What is the next possible tour? A. Next is
D,
D. Next
C,
is C.
B,
B.
A.
A. Clear pa?
Yes, ma'am.
What distance he traveled? A to B years.
7
to
plus
7 plus
1 plus 8
1
plus
plus 8 plus
2,
2. Total
18
value is 18, right? So a similar way, you need to find all the
possibilities.
values. Okay, this is called as what? Traveling salesman problem. This traveling salesman problem is used to find the shortest distance, right? Based on the Hamiltonian. Next is